I graduated from a technical college in year 2000, and I started working in the same year. I started using SOLIDWORKS since 2005, and I'm still learning new things. I am a certified expert and a champion. I'm one of the winner for Michelle Pillars Award. And I was recently recognized as a SOLIDWORKS hero. I work as SOLIDWORKS design consultant at Vishnu Design Services. It's an engineering services provider company based in India, and I work with a lot of companies around the world to help with them their SOLIDWORKS related need. That could be modeling, drawings, animation, or automation things, which is being done using macros, add-ins, or standalones. I'll quickly go through the agenda for today. We have been working with SOLIDWORKS drawings since our last two sessions. So we will be continuing our journey with the SOLIDWORKS drawing, and we will be covering the following tools and views: flat pattern view, dimensioning properties and style, all callout, and then Centermark and Centerline. So let's not stretch this thing further and straight away jump onto the presentation. Flat pattern view. Now, why flat pattern view is required? So before we go into the SOLIDWORKS and see how flat pattern view is being made, we need to understand why this is required. Flat pattern view is mostly required in the sheet metal industry, and why they need it, so that they can work out the sheet size they would need to make any particular sheet metal component. So basically, flat pattern, what it does, it shows an unflattened shape or size of a sheet metal part. Now, how we can create a flat pattern view in drawing is when we bring in a sheet metal component into a drawing mode. SOLIDWORKS give us the option of creating a flat pattern view in the same property manager, or we can also do when we insert the model view, from there also we can select the flat pattern view in the property manager. There is no a direct tool to insert a flat pattern view directly into the drawing. We need to have a model view first, and that should be of a sheet metal component, and then SOLIDWORKS will automatically give us the options for a flat pattern view, unless you are using the task pane. In there, if you have a sheet metal component open up and you are doing the drawing for it, SOLIDWORKS will automatically show you a flat pattern view over there. So how does a flat pattern view looks like, and what information or what details it can give to us? Now let's look at one of the example. So I will open up a drawing in SOLIDWORKS. Now it's a sheet metal component. I have given some basic drawings, but now my shop people or the shop person needs to know what is the sheet size he need to cut or she need to cut to manufacture this part. Now what I'll do is I will insert one view. So I'll go to insert drawing view, model view, like we have been doing. And if the model is not open in the background, I can go to browse. Let me just open up the model. Now I have the model open up, and you can see, because for me, SOLIDWORKS for this component, since the flat pattern view was already created, SOLIDWORKS give that option under the drop down in configurations, or I can pick. If the configuration is not available, you will see the flat pattern view under more views. So I will select this view, and then I can place the view over here. Now, once the view is placed, you can see we get two things in the view. One, it gives us the bend angle along with the radius, and it also gives us the direction, whether the bend is upwards or downwards. Now, people in the industry, in some industry, they prefer the bends or majority of their bends to be upwards, because they want to preserve the outer surface finish of their components. And in some industry where they want to control it through the outer dimensions or the outer profile, they tend to use the downward directions. So SolidWorks gives us options for both the things. We can use the up direction as well, and we can use the down direction as well. Now, how to do that and how to orient the view, because right now it's looking like though it is in the space, but it's not looking neat. So what we can do is we can click on the view, and then you will see the option flat pattern display. There you can define if you want to rotate the view 90 degree, 180 degree, or 270 degree. So we can keep it 90 degree, and under the same flat pattern display option, you see flip view. Flip view means the side of the view which is now normal to the screen will be rotated. So if I click on flip view, you can see that the direction of the bends has now changed. Now it is showing down 90 degree. Earlier it was up 90 degree. Then the second important thing which flat pattern gives us is these lines. These lines are called bend lines, and why these are required, though not all industry use them, but the industry which use them, these lines help the people on the shop floor to know from where they have to do the bending of the part. So in case we don't need these bend lines, we can just right click and hide them. But the thing is, like, the moment we hide the bend lines, SolidWorks will automatically hide the bend nodes. So we'll say, okay, and this is how you get your flat pattern shape. So in case you want them back, just click on the view and then select the bend lines. And for the bend nodes also, you can click OK. So this is how you create a flat pattern view. Flat pattern view is only available for sheet metal component. And let me just open up the model, please, first. So what happens is when you create a sheet metal component, SolidWorks will create the desired configuration for it. But the moment you create a flat pattern view in the drawing, a default flat pattern configuration will be created for that particular configuration. So so basically SolidWorks is creating a derived configuration under the active configuration for which the flat pattern view was created. So, and the only difference between the flat pattern and the default configuration is, so when you activate it, it shows in the flattened state in the model as well. So basically it is unsuppressing the flat pattern feature. So if you go back and you move to default configuration, it will go back to the flattened state. So we'll save this drawing. I'll close this drawing and we'll move on to the next one. Now, the next important thing is dimensioning. Why we need dimensioning and what is the use of the dimensioning? So dimensioning, what is the size of a component? Right. It basically gives us like what is the difference between if there are two holes, for example, or two slots or two pins. So what is the center distance between them, or what is the angular distance, or what is the angle between two entities that are not parallel or perpendicular to each other. Now, there are various type of dimensionings which is being used. right? So we will be covering some of them. Now, how to do dimension? We can click on the required dimension type on the dimension toolbar, or we can also go to tools, dimensions, and pick the required dimensions. So let's look at a different type of dimensioning. So first we will be talking about the driving dimensions. Now, what are driving dimensions is the driving dimensions are those which, where when you edit them, the geometry or the shape or the position of a component or a whole that changes. Now, how do usually driving dimensions people have seen in the model only, but we can have the driving dimensions in the drawing as well. Now, how to have driving dimensions in the drawing, which can basically change the shape of the model from the drawing environment itself. So we'll go to the dimension. It is not available, so no problem. We'll go to insert and model items. So when we click model items, I will say entire model, import into all views. And other than dimensioning, you can also pick a few other things, like if you have any whole callout, or if you have any other the geometries or other annotations. So for now, we'll be using only dimensions. So I'll click OK. And SolidWorks will SolidWorks will add the dimension in the same way, in the same position it is there in the model. Now, what I want to do is say, for example, I want to edit this dimension from 22 to 25. Now, instead of going to the model view, to the model, changing dimensions over there, what I can do is I can change the dimension over here by simply double clicking. So I'll say 25, and I can do a rebuild, and the model is updated. Why this happen is because these are driving dimensions, or in drawing terms, we call them model items. So any change we make in these dimensions over here will be taken back to the model. And when you save them, both the drawing and the model will be updated. I will change it back to 22. I'll save the drawing, right? So next one is driven dimensions. Now, so driven dimensions are those which we cannot change, and they are being driven by some geometry or some entities, or basically we can say them, they are dependent on an entity. So now, how to do the dimensions? There are various ways to do the dimension. So SolidWorks give us an option called smart dimensions. So with a smart dimension, you can do vertical dimension, horizontal dimension, angular dimension as well, radius dimension. So with one single dimension, you can capture a lot of the dimensions. So let's click on smart dimension. So I'll pick on this dia, then this dia. Now I have to place them away in the direction I need. So what I can do is I can click on rapid dimension in the dimension property manager. Now see what will happen is, once you create a dimension, it will give you two half circles, one on the orange and one with the blue color. So if you click on the orange side, it will place the dimension on the left, and if you click on this side, that will get highlighted and the dimension will be placed on that side. So let's do it that way. Now I will give dimensions from here to here. So, and then let's have another dimension from here to here, and then the overall dimension. Now with the driven dimensions, you cannot simply double click and change them. So for any changes, you will have to go to the model and make the changes over there, and the drawing will get updated. Now let's open up the model, and we'll simply change this dimension 12 to say 10. So our dimension is updated, right? So I'll make it back to 12, and my drawing is updated again. So we see the difference between driving dimensions, which drives the model geometry, and the driven dimensions is which are being driven by the model geometry. So for any changes, we'll have to go to the model. Now, next is ordinate dimension. Now, lot of industry use ordinate dimensions where they define a datum or an origin, and then they start placing their dimensions. So it is very helpful when you have steps or holes or some shapes to show where you need to build on or add on to the previous dimension. So there are two ways to do an ordinate dimension. You can simply click on ordinate dimension. It is again similar to smart dimension, where you can do ordinate, vertical ordinate, or you can do horizontal ordinate in one go. So I'll pick ordinate dimension. Now, for ordinate dimensions to start, we need to define one edge as my starting point. So I'll pick this edge and I'll position my 0 over here. So this point will be my 0, and then I can simply click and then I'll press escape. So without having to click so many entities again and again, I simply clicked on the edges and it automatically picked up the desired points for me, and it gave me the desired values of the dimension. So someone who is working on the CNC, they can set their 0 point over here, and then they know they have to go 50 for this hole and 225 for this hole, and final the outmost edge is 275. So let's do one more dimension in this direction. Now this time, instead of selecting the ordinate dimension, I will pick the vertical dimension, and it works in the same way like we did. So now the person knows that in this direction, these holes are on 50, then 125, and then 200. So we can also pick points as well if we need to define the ordinate values, like something is at an angle and you cannot pick that edge because it is in an angle. So you can select the vertices, or even if you have some center marks, you can also select the center marks to place your ordinate dimension. Now, this is a linear ordinate dimension. In few recent versions back, SolidWorks also introduced angular running dimensions. That let's see how that is useful. So what I'll do is, like, I'll first pick the ordinate dimension just to explain. So I selected this one, and I will do it on the other side as well. So this, sorry. And now the problem with this one is, like, there could be confusion, like, or the user will have to calculate what exactly is the distance and where they should keep their zeros, or because these are in decimal places, right? And they will be moving the table, their measurement tables or their Y's in angular movement. So instead of like linear direction, what we will do is we will give them the angular direction along with the PCD. So I'll click on angular running dimension. I have selected. Now, so what I've given them is like that the first hole is at 0 degree, the next hole is at 45 degrees, the next one is at 135, and the next one is 180, 225, and then 315. So what they can do is, like, they can start from one direction and then they can make a 360-degree turn. And if you do not want to do that, what you can do is you can select the dimensions, go to the leaders, and then you can do run bidirectional. So SolidWorks will automatically change the dimension style, or you can also, if you want to extend it towards the center of the arc, so that we can show to the person reading the drawing that everything is at the center of the drawing. We can do that, right? And then if you do not want to show as a chain dimension, you can simply uncheck this, the under leaders, you can simply uncheck display as chain dimension. So what SOLIDWORKS will do is like it will remove all the arrows and making the drawing look much neater, especially when you have a lot of angles to add or a lot of values to add. So having some extra lines may clutter the drawing. So instead of that, you can just do this. Moving on to the next type, we have baseline. Baseline is a dimension where is similar to ordinate dimension, where we define one edge or one point as our starting point, and then when we select on the dimension, it will add the dimension between that our origin or the first entity and then the next selected entity. So unlike ordinate dimension where it keeps on adding, right, it will create a new dimension from our defined origin entity to the selected entity. Now let's look at how does it looks like. So what I'll do is like I'll click on the baseline and I will set this edge as my base point. Now I click on this one, and this one. So you can see we took just 4 clicks to do these dimension. If I had to do a small dimension or horizontal dimension, for example, so I will have to click 1, 2, 1 dimension, 1, 2, second dimension, and 1, 2, third dimension. So instead of doing 6 clicks, the task was completed in just 4 clicks. So that is another advantage of the baseline. And then the dimensions are also interlinked. So if you move a dimension, right, all the dimensions will move. Whereas in this case, single dimension will move. So this is how we use the baseline dimension. Now, next is a chain dimension. Chain dimension is again similar to baseline. We start with one's first entity and then we keep on adding the dimension. But the only difference is like it will add the dimension between the last entity and the next selected entity. So instead of like starting the dimensions from the defined 0 point, it will add the dimension between the last selected entity and the current selected entity. So now let's look at the chain dimension. I will select this line as my starting point. Now this edge, so this dimension, then this dimension, and then this dimension. So you can see like we just did 1, 2, 3, 4, 5 clicks instead of like 2, 4, 6, and 8 clicks. So instead of 8 clicks, we were able to finish the task with just 5 clicks, and it looks much neater. They are all interconnected. If I had to do, for example, the small dimension, 1, then 4, 6, they are not linked. Whereas they remain linked. So even if we move them far away, because they are in the chain, we can break the chain if we want. We can right click and convert to base or remove from chain, right? So we can remove them from the chain and the dimensions will behave independently. But since this is looking neater than this, I will still keep them in the chain scenario, chain dimension scenario. The last one we'll look at is the chamfer dimension. We do put chamfers in the drawing, in the models, and sometimes we need to show their dimensions. Generally, we put a note on the drawing that that under undimensioned chamfer or not defined chamfers are 1 mm into 45 degree or 2 mm into 45 degree. But sometimes we need to give dimensions to the chamfer dimensions as well. So let's look at one quickly. So I'll click on chamfer dimension. You pick the the edge first. So there is a difference, like the value. So you need to click on the chamfer edge first, and then you can pick either this edge or this edge, and you get the dimension you want. So let's try with this face, and we can see the difference, what will happen. See, so the selection is important when you are doing the chamfer dimension, that you need to click on the chamfer first, and then you can click on the edge, and then SolidWorks will give you the correct values. So I will close this drawing. I'll close this model and we'll jump onto the next one. Dimension properties and style. So we have seen a lot of dimensions types being used in the drawings, and but there were something missing in the drawings, and we call them drawing styles and properties. Now the drawing properties are being controlled by the document options. You can find them under tools, options, document property. But what happens in case if we need to change the style or the property of an individual dimension or some selected dimension, because there was a requirement to do that. So instead of making a global change on all the dimension, what we can do is we can change the dimension properties or style for particular dimensions. And to do that, simply select the dimension or the dimensions you want to change, and then make the required changes. And then SolidWorks also gives you an option that if you are making a change or a series of change to dimensions style, and you want to use it for your next drawings, or if you want to use it in the same drawing on different dimensions, then without having to redo all the steps, what you can do is you can save the style of that particular dimension, and you can simply apply it to the next dimension. So let's open one drawing up. Now let's quickly add dimensions to it. So what I'll do is, like, I can do model items. So I'll select this view. I'll say import into all views. Now these dimensions are there, and I want to give some specific properties to some of the drawings. For example, for this drawing, I don't want to give for this dimension, I don't want to give any tolerance, and I want to keep it basic. So I will simply click on it, and I will change the tolerance type to basic. Now, what we were talking about, the document properties. So I can go to the tools, options, and document properties. So the dimension, all the dimensions, styles, and properties are being controlled from here, right? But because we want to make changes to selected dimensions or to some specific dimensions only, and instead of changing everything globally, what we can do is we can select. So for this example, for this one, I want to give a tolerance of, say, +0 and -1. So I can change the tolerance to bilateral. So I will say plus, say, 0.5, for example, and -0. So I have changed the property or the style, sorry, the property for this dimension only. For this particular dimension, I will want to tell them that this particular dimension or dia needs to be chrome plated. So I can type in chrome plated. Now I am not making changes on rest of the dimensions, but I'm just making changes on some specific one of them, right? Now, for example, I want to have this particular one in dual units, because the material which is going to be supplied is available in inches only, and my drawing is in metric. So it creates a lot of confusion at the vendor end, because the material standard lengths are available in inches only. So what I can do is I can click on this dimension. I can go to leaders, and then I can, oh, sorry. No, sorry, under values, sorry. Yeah, under values, if I can go down, you will see option of dual dimensions. So I can select dual dimensions. So now what is happening is the main dimension or the basic dimension is being given in metric, and it is being converted to inches as well, so that the vendor can easily understand, and he doesn't need to, or she doesn't need to spend any time calculating what will be the exact length in inches, right? Now I want to apply the same dual dimensioning unit along with, let's say, some tolerance of symmetric, sorry, say 0.25. So plus minus 0.25. So I want to apply the same style to, for example, this 20 dimension as well. Now I have two options. First is I click on 20, change the from bilateral to symmetrical, and then switch on to the dual dimension. And if I have, say, 10 more dimensions to do that on different sheets, so I'll have to go them one by one. So instead, I will click on this dimension, and you see an option called style. So I'll click on add or update style, and I will say dual dim plus symmetric tolerance, basically. So I'll click OK, right? So now I have saved the style. I'll click on 20, and now in the drop down, it is quickly changed. So even if I have to do for these two dimensions also, I can do that. So you can see when we are saving the style, we can use them. This is a similar tool. We call them, like in the paint, we have a tool called apply painter. So you pick a color and then you can apply it on the other entities in the paint tool. So similar way you can do that. And if you want to use the style on different drawings as well, what you can do is you can export the style, right? And then when you go to the new drawing, you can load that style. So that style, unless you remove it from the drawing, it will stay with the drawing in that particular drawing only. So if you have to remove a style, you can make it activated, and you can then click on remove. Now that style is gone. But because you have exported it, you can keep it in library, and if you have to use it repeatedly in your other drawings, you can call it from the library by just click on any dimension, and then you can click on load a style, and then you can browse to that style. Oops. It looks like I removed it accidentally. Anyway, so that's how you work with the drawing properties and drawing style. And let me just call one more view. Insert model view, browse. Oh, this is what I need. I will change the scale to 1. This is just to show you. Now, for example, I'm doing the drawing. Say I did. Now, what I want to do is I want to have the dimensions from the outer. Assume these are not holes, these are pins, extruded or pins coming out of the plate. And I want this dimension not from the center, but either from the inward inside of the pins, or from the outside face of the pins, because I want to know like what is the outer distance. So I can click on this dimension, And then you can go to the arc condition where you can define you want a max condition for the arcs or you can want a minimum condition for the arc, right? This is for the cases where you accidentally did from center to center. If I have to do dimension and I know I want the dimensions to be done from the outer to outer, you just press on the shift button, you select the outer side of the arc, select the outer side of the arc, and then you can automatically get the outer dimension. And similar way, you can do the inside dimensions of this inside, and so you have to keep the shift press, otherwise SolidWorks will automatically start the dimension from the center of the circular edge. So I'll save this drawing, close, and we'll move on to the next one. Hole callout is basically another type of dimension, or you can say annotation, which defines or which is used to define the size of a hole slot, if it is not, if it is a through hole or if it is a blind hole, and then what is if there are more than one hole in the in the model, then what are the instances or the count of the holes. So we can click on the hole count on the annotation toolbar, or we can also go to insert menu, then annotation and hole callout. So let's look at few hole callout. Now, there is one catch in the SolidWorks, that it will count the instances of the holes which are being created in one single feature. So if I have these two holes and they are being created in two different features, even if the sizes and the depth is same, SolidWorks hole callout will treat them as different. Now let's do a callout. So I'll go to the annotation toolbar and I'll click on hole callout. I'll select the edge and it says 2x dia 5 through. So 2x is the quantity because there are two, they are being created in the single feature. So 2x denotes that the instance of the hole, and dia 5 through means the size of the hole is 5 mm and it is through hole, right? So let's try on this one. So in this case, it says 3x because there are three numbers. Then dia 3.4 through all means the smaller holes is through all the component, whereas then we have a symbol of counter bore, which is denoted by a U shape, and then the dia of the counter bore is given 8.4 and its depth is given as 2.30 mm. So if I, let me just open up the model. So what I'll do is like, I'll add one more hole. I'll say just dangle. I'll position them randomly. I will just positioning them randomly. So I have created one more set of holes using the same size and the end conditions, but SolidWorks will not add those numbers, those two additional numbers into this count, because these two holes were created in one feature and these two holes were created in another feature. So SolidWorks will not add them into the instance. So either we need to create another hole callout, or what we can do is we can click on the hole callout and just overwrite the number over here. Now that help us to give the exact number, but the problem is like in case you change you add or remove any number of hole, you will have to manually change the quantity over here. Now, there are a lot of people ask, like, can we customize this call out? Yes, you can customize this call out. There is a text file that derives this call out. So you can go to the location of that call out, create a backup of that file first, and then the instructions are given in the same file itself, and then you can make your customization. That, for example, they want, sometimes they said, we do not want to add a word through, we want to add a different word to it, or we want to add another detail in this call out. So that can be done by customizing the whole call out file. Right. Now let's look at a few more whole call out. So I'll go to the whole call out, and this time I'm just doing a thread. So since it is a thread, so in this particular case, it gives us two different values. One is the drill dia for that particular thread. So it says 8.5 into 25 mm depth, and then the size and the class, the class of that particular road. So it's M10 6H and depth 20 mm. So if I show it in over here, so this is my drill depth, and then this is my thread depth. So SolidWorks gives us both the option. Again, this can be customized. Like some people say, is we don't want to show the drill size. We just simply want to show the thread size, so they can customize their requirement. I mean, like they can customize their whole call out file. SolidWorks callout can be used to define the size of a slot as well. So I can use and click anywhere on the slot, and it gives the outermost size of a slot. So if I'll show you in the dimension, I have pressed Shift. So this is 50 by 50. And SolidWorks callout can be used to give callout to features which have been made by cut extrudes as well, right? But they needs to be circular in edge. So I can just click on this circular edge, and it says 18.5 and through. Then you have these holes. These are countersunk. These are counter bore, and then these are countersunk. So you can see there is a difference in the icon. So the U shape designates the counter bore, whereas a V shape designates a countersunk. If we have to look at how they look like, so this is the countersunk, and then this is a counter bore. I'll save this drawing and close. Center lines or center marks. Center lines or center marks. Center line is basically used to show the circular or cylindrical feature in a drawing. So it's basically indicate that either there is a hole and we are looking from the side of that hole, so it gives us that it's a cylindrical hole, or if we are looking at a shaft from the front view, and if we do not put the center line, the view may look like, if it is a straight cylindrical shaft, the view may look like it's in a rectangle. So we put center line to indicate that it is not a rectangular or a cuboid shape, it's a circular or a round cylinder. Then a center mark is used to show the center point of an arc or an hole, right? And using that, we can indicate that this is the center point, and we can reference to that center point to either define the positions or for other things, we can click on the center mark, center lines on the annotation toolbar, or we can go to the annotations on the menu, and then we can click on center line and center mark. So these are two different tools, but they are similar in nature. Like, so let's look at the drawing. So I have the center line and the center mark on the annotation toolbar. In case you don't have the annotation toolbar, you can create the annotation toolbar, or you can also go to insert annotation, and then you can find them over here, center mark and center line. Now let's start with the center mark first. Now when we start center mark, SOLIDWORKS gives us a lot of options. So first one is when we are talking about manual insert option right now. First option is called single center mark. Then we have option called linear center mark, where it creates a pattern of the center mark, where the center marks which are in linear line, they will be connected. And then third one is the radial one. So, or the circular one, we'll look at it at this one. So let's look at the first single one. So when we click on single, we can just simply select on the circular edges and the center marks will be created. I will delete them all, and I'll go back to the center mark. And this time I will pick linear center mark. So it gives us option that do we want connections lines or not? So let's keep the connection line and now see what happens. Let me just change. So what SOLIDWORKS does is it will create a connection lines between the center marks. So how these connections lines are helpful? They basically helps us to indicate that these holes are in one line, horizontally as well as vertically. Otherwise, we will either have to assume, we either will have to give the dimensions for both the holes on both the sides, because unless there is some difference in the holes position, we can use the center lines, the center marks, to define that the holes are in one position. So I can just simply delete them. Similar way, we can use the auto insert option. We can click on all holes, but sometimes it doesn't create the connection lines, right? We can also pick if we want to have the center marks for the fillets, for the slots. So we can select them, and then it will create the center marks for the fillets and for the slots as well. Now, assume this was our front view and we were seeing the holes and the circular edges are visible. Now, when we are looking at the side view, and assume this is the only view available to us. So unless we define something for these cutouts, one can assume these are square or rectangular cutouts. So to avoid that confusion, what we can do is we can use the center lines. We can auto insert, and we can select the view, and it will automatically insert the center line. Now, with these center lines, it gives a clear indications to the person reading the drawing that this is not a squarish or a cuboid or a rectangular cutout, but it is a circular cutout. Now let's talk about the third type of center mark, which we were looking at, the circular one. So with that, first let's try to do one manually and see what happens, and or maybe auto insert. So for auto insert, when we do auto insert in this, it creates the connection lines, right? But what if we want to create these connections line manually? So you go to the circular center mark type, you click on one of the center mark, and SOLIDWORKS will automatically give you the option to propagate, because it has automatically detected that there are more holes in the pattern. So I'll click on them, and then SOLIDWORKS will automatically create the required pattern for us. Let's remove it. And if we have to do it manually, then that means you will have to click on individual. Now, the disadvantage of doing this is that the lines are not inclining or not pointing towards the center, right? So they are not looking good. So let's remove them, and then we can use. So this is looking much nicer, where the lines, the center lines are pointing towards the center. And if required, we can change the size of a selected center line, the center mark. So we can just click on it and then drag in the direction we need. Same thing we can do with the center line. So let's insert center lines over here. So I'll say, sometimes if it doesn't work, so you can pick the edges. Now, for example, I want to extend this center line out till here. So I can click on it, and then I want to do with this one also, for example, so I can extend this. And the advantage of using center line, and another advantage of using center line and center marks, is that you can do dimensions with respect to them. So for example, if I have to click this one to define an angle, I can use the center marks line or the center lines to give dimensions as well. Right. Now that concludes our topics for today. Right. So I'll be happy to answer any questions a user may have.
Hello, Deepak.
Yes, hello. Please.
Rahul here. I am following you from from few months. Yes, is there any chance that you can arrange the session for SOLIDWORKS API, basic of API?
Okay, I can do that. So I'll note it down, and I will see when it is a good time to do a basic of SOLIDWORKS API. I'll note it down and let you know. So can you please ping me on LinkedIn or another any other social media site, and then we can connect if we are already not connected. So let me just.
Yes, I will do.
Yeah.
Okay. So and today's session is very informative. Yes, today's session is very informative. Lots of you do last one, that is a center line or center mark.
Yes.
Okay, I am using it a lot of times. Use it, but I never saw this, that it can use for arc plus linear. Yes.
Okay, thank you. Appreciate that the session was helpful. At least you were able to get something out of it. Thank you.
Yes. Thanks to you for arranging this.
Actually, thank you should be to the Uganda team. They arranged the session, and I'm just sharing my knowledge. So thanks to Derek actually for arranging this session. Right.
Yes.
So okay.
Hello. Hello.
Yes, please.
Yeah. How are you, Gupta?
I'm doing great. Thank you.
Thank you. Last time they told us you were sick, so we are all praying for you to.
Thank you very much. Yes, I'm recovering well, though it's a little slow.